All right, number 2. That's 3. Number 2, it says the recursive formula of an arithmetic sequence is described below. And it says f of 1 equals 19, f of n equals f of n minus 1 plus 6, which represents the explicit equation of this arithmetic sequence. So again, this is the recursive one where it's talking about where you have to show the previous term is being, in this case, added by 6 each time. The way we can show it in an explicit version, I'm going to go ahead and I'm going to rewrite it the way I would, okay, using the definition that we had, or the cheat sheet that we used. And it was f of n. We'd have f of n equals f of 1, our first term, and the first term's right here, 19. And it looks like we're adding 6 each time. So I'm going to do plus 6 times n minus 1. Okay. So taking a look at which one of these equations looks most like what we would have done here. And I know 19 is the key here, right? And we're starting with 19. And then in this case, they were adding, they have the 6 times n. This actually should be n minus 1 with the way that it's set up, where we have f of 1 equals 19. If it was f of 0 equals 19, we could have used this one, but in our sequence, with sequences, we don't have a 0 term. We should have a first term. So should be B is what the correct answer should be, because that's the only one where we have 19 by itself as our initial term. Right? And then you're multiplying 6 times the number of terms that you're going to be moving forward. But that 6n, that should be an n minus 1. When we have a question like this on the test, I'm going to make sure that it does show the n minus 1. But B is the correct answer for this one. Number 3. Oh yeah, if you need me to go over any of these other ones, just speak up, yell at me, get my attention. Or if you're at home, post a little chat. Number 3. Answer each question based on the following arithmetic sequence. So we have 13, 10, 7, and 4. Well, I know it's arithmetic, so the first thing I'm going to do is I'm going to look and see what I'm adding or subtracting each time from one term to the next. And it looks like I am going to be subtracting 3. So when I go from 13 to 10, each time I'm going to be subtracting 3. Part A, for the sequence listed above, what is f of 1? So what's the first term? 13. Okay. F of 1 represents what the first term is, so we just look and see what the first term, 13. Part B, for the sequence listed above, what is f of 3? So that they're asking, what is the third term? What is the third term? Well, 13 is the first, 10 is the second, 7 is the third. 7 is the third, so I'll go down over here. F of 3 is going to be 7. Part C, for the sequence listed above, what is the explicit equation? They've actually got solutions down here that we can pick from. And we get, starting with 13, and then we are going to be subtracting 3 each time. So we would get, if I were to write it myself, I would get f of n equals 13 minus 3 times n minus 1. Okay. So which one of these has a 13 by itself? That's a negative 13. That doesn't work. Okay, D looks like the only one that has 13 by itself. Let's see if the rest of it works out. I have a -3 times n minus 1. Here they have n minus 1 times -3. This will end up being the same thing. Adding a n minus 1 times -3 is the same as subtracting on 3 times n minus 1. So D will be the solution for part C. All right. Moving on. Number 4. Consider the following sequence and type the next number in the sequence. Well, we have to identify, is it arithmetic or geometric? From 93 to 85. I always check arithmetic first, just because it's a little bit easier to figure out the addition and subtraction than it is the multiplication at times. So I'll check and see if I'm adding or subtracting something here. So from 93 to 85, I would have to subtract 8. And if I subtract 8 again from 85, that does give me 77. And from 77 to 69, I'm subtracting another 8. So it looks like I'm subtracting 8, which makes this arithmetic. So I'm going to go 69 minus 8, and I get 61. Okay, 61. This is an arithmetic sequence, so we just continue to subtract 8. Pretty straightforward one there. Okay, this one, I like this one. This requires you to kind of think about an arithmetic sequence and determine what the two middle terms are when you're given the first and the fourth. Okay, so in the first one, first term was -20, the fourth term is 19. I know that I'm going to be adding something because I've got to go from a -20 to a positive 19. Here's the way that I would do these problems. Okay, I know that I'm going to be adding something 3 times. So once here, once from here to here, and once from here to here in all 3 of these rows. Okay. So what I'm going to do is I'm actually going to I'm going to figure out what the difference is between -20 and 19. Okay. I'm going to figure out what the difference is. So I'm going to do 19. I'm going to start with the bigger number and subtract, or I'm going to start with the number on the right and subtract the number on the left. So 19 minus a -20. Well, subtracting a negative is like adding a positive. So that's 39. Now I know that I'm going to move 39 units from left to right. Okay. And I've got to add something 3 times. So if I take 39 divided by 3, I think I'm going to be adding 13. Now we got to double check and make sure it works. And you could do it this way, the way I'm doing it right now, or you could guess and check. You could pick a number like, I don't know, maybe 9 works. Add 9 3 times and see if that gets you to 19. If it's not enough, if you're short, then increase your number. Okay. With an arithmetic sequence, it's pretty straightforward how you're getting from one to the next. You're either going to be adding the same thing or subtracting. So guess and check would work. It might just take you a little longer. So -20 plus 13 is -7. -7 plus 13 is 6. And 6 plus 13 is 19. So that one works. All right, let's look at 54 to 105. Again, I know I'm adding because I'm going from a smaller number in the first term to a bigger number in the fourth. So I'll do 105 minus 54. Looks like this is 51. 51 divided by 3. It's 17. So if I keep adding 17, 54 plus 17, let's see, that's going to be 71. 71 plus 17. 88. 88 plus 17 is 105. That works. All right, now the third one, 10 and negative 14. This one, I'm getting smaller, so I'm going to be subtracting something each time on this one. Negative 14 minus 10 gives me a negative 24. So I'm going down 24 units from the first to the fourth. I'm going to divide that by 3. And I get a negative 8. Well, let's try and subtract 8 here. 10 minus 8 is 2. 2 minus 8 is negative 6. Negative 6 minus 8 is negative 14. There we go. All right. Okay, you will have a problem similar to this on your test. Just some different patterns. Okay, but good practice for you. I'm recording this right now, so I will post this if you guys need to go back, like if you're completing your review after class today, if you want to go back and look at it, kind of see the step-by-step process of solving these. Somebody just arrived to class. All right. Number 6 says Monell created a sequence of the following numbers: 13, 9, 5, 1. What is the common difference of Monell's sequence? So common difference is something used in an arithmetic sequence. So basically, what am I adding or subtracting from one term to the next? And we are subtracting 4. So a common difference here, when you write this, you can't just write 4, because then I don't know if you're adding or subtracting 4. All right, so we would put negative 4 in there. Okay, the common difference is a negative 4, because we are subtracting 4 each time, or we're adding a negative 4. What is the 10th term of Monell's sequence? All right, now actually part C would actually help us out a lot in order to determine B, because that's our explicit rule, which means that you could plug in your nth term value, like the nth term value in there, and it would give you what the nth term is. So I'm going to go ahead and I'm going to work on C, and then I'll go back and figure out what B is. So C, we got f of n equals the first term, 13, plus or minus your common difference. I'm going to use, so we got minus 4 times n minus 1. Okay, so 13 minus 4 times n minus 1. All right, let's use this explicit rule to find our 10th term. So I'm going to figure out what f of 10 is, because n represents the term number. F of 10 equals 13 minus 4 times 10 minus 1. All right, well, we know I don't know why that looks like a 9. I might have put 9 in there subconsciously. 10 minus 1 is 9. So f of 10 equals 13 minus 4 times 9. All right, 4 times 9 is 36. So 13 minus 36 is a negative 23. So that means our 10th term equals negative 23. Okay, and that makes sense because we're going down 4 each time. And our numbers started as an odd number, and if we keep subtracting an even number, we're going to keep having odd numbers. And that looks like that should be about right after 10 terms. Okay, so again, I kind of looked ahead and saw that that third part C there would help us with part B. All right, now you could have easily just written out on a sheet of paper your 10 terms, just subtracting 4 each time to get negative 23. That would also work. More than one way to get the correct answer here. Number 7, given this explicit rule, complete the table for the first 4 terms. All right, this one's pretty straightforward. We got n is the term number. 1, 2, 3, 4. Okay. And so you have n is 1, 2, 3, 4. That's the first 4 terms. Again, you could plug 1 in and get your next term. So 5 minus 3 times 1, which would be 5 minus 3. Which again, I thought that I had switched these, but I must not have. This should be n minus 1. If 5 represents f of 1, okay, then we would need this to be written like this. F of n equals 5 minus 3 times n minus 1. All right, reason being, if I just would have left it as 3 times n, then the first term would be 5 minus 3, which is 2, and that's not the case. The first term should be 5 based on our definition. All right, so I'm going to switch it up a little bit, at least in the explanation here. So 5 times 3 times n minus 1, that means that this first term over here will end up being 0 because it's 1 minus 1, which is 0, and 3 times 0 is 0. So our first term will be 5. Second term, 2 minus 1 is 1. 3 times 1 is 3. So you get 5 minus 3, which is 2. When we go up one more, it'll be 3 minus 1, which is 2. And 3 times 2 is 6. So 5 minus 6 is a negative 1. And when we plug in 4, we'll end up getting negative 4. Okay. In this one, I mean, the pattern here is you're subtracting 3 each time. Okay, 5 minus 3 is 2. 2 minus 3 is negative 1. Negative 1 minus 3 is negative 4. If you can identify from the rule what's happening there from one term to the next, you don't have to plug your values in and use the equation. You could do it all by hand, okay, and just move your sequence along that way. That's one benefit of understanding how these functions are generated, is that you can identify the different pieces, like your starting point at 5, and then your common difference, which is negative 3 here. It says, evaluate the following question for f of 3. So this is one where we are evaluating, we're plugging it in. This is good function practice. So f of 3 equals 6 times 3 minus 1 plus 9. So whatever is in place of x, which is the 3 right here, I have to place in place of x in the equation. So 6 times 3 minus 1 plus 9. 3 minus 1 is 2. And 6 times 2 is 12. 12 plus 9 is 21. So f of 3 equals 21. All right, 2 left. Arrow. Which formula defines the sequence? All right, well, we have to identify arithmetic or geometric. So from 2 to 6, I'd be adding 4, 6 to 10, adding 4. Good, it looks like I'm adding 4 each time. Because I go 2, 6, 10, 14, 18. All right, so I look and see which one involves adding a 4. And it looks like it could be B or D. It could be B or D. Let's see, where am I starting? I'm starting at 2. Well, between B and D, the only one that starts at 2 with F1 at 2 is B. So I think B is going to be my answer. Let's just double check though. So starting at 2, the next term equals 4 plus the previous term. And that does make sense. Okay. B is going to be our correct answer here for this one. Okay. And again, I just read that as what these function things mean. F of 1 means the first term. So the first term equals 2. F of n, the next term equals 4 plus f of n minus 1, which stands for the previous term. Last one. The sequence is defined by f of 1 equals 3 and f of n equals 2 times f of n minus 1 for n is greater than or equal to. Which of the following statements defines the nth term of f? Well, this recursive definition is showing us a geometric sequence because we have f of n equals 2 times the previous term. All right. So right away, that should tell you that we need one, and that's why the cheat sheet's going to be helpful. If it's geometric and I want the nth term, it's going to be one of these two, either C or D, because these involve exponents, okay, where n is an exponent. All right, well, if f of 1 equals 3, it's still going to be a C or D because it starts with your first term, 3. It says, which of the following defines the nth term? So we're multiplying times our growth factor, which is 2. They both do that. But we need it to be n minus 1 because we're told that f of 1, your first term is 3. Right? If we would have picked the bottom one, then what would happen is the sequence will be shifted off 1 from where it should be. And I can kind of double check to make sure this is true. If I look at my first term, so got my first term, which is n. Here's f of n. So my first term should equal 3. So if I plug in 1 for n, 3 times 2 to the 1 minus 1. Well, 1 minus 1 is 0. Anything to the 0 power. You could have a million to the 0 power, but anything to the 0 power equals 1. And 3 times 1 is 3. All right. This kind of verifies that it goes for this first one right here. Okay? That it is going to work for that. If I were to plug 1 into this part D formula, that's 3 times 2 to the first power. Well, 2 to the first power equals 2, and 3 times 2 equals 6. All right, so I would have gotten 6 here from f of n. Well, 6 is what the second term is going to be. All right, so it kind of would shift our sequence one. Amanda. Like you can't see them? Try reloading the page. See if that because I think I'm looking at the same one you are. All right, I'll come back there and help you out. I'll see if I can help you out.